Hi, everyone. So this week we're going to be covering a couple of topics from Chapter 5, namely Geometry and Trigonometry 2. And in this chapter, we're going to be studying arc length and area of a sector. Now, we're talking about circles. So in this example, what we have is a pizza, and they tell us that the pizza has a total area of 120 centimeters squared. The pizza is cut into 8 equal slices. This word is important, as shown in the diagram. A, what is the area of one slice? Okay, so this problem is pretty simple because if the whole pizza is 120 centimeters squared in area and it's cut into 8 equal slices, then each slice has to have an equal area. So that means that one slice has to be 120 divided by 8. And that equals 15. So 15, and don't forget the units, 15 we have to write centimeters squared. So that would be the answer for A. How about the total area for 3 slices? Well, if 15 is one slice, then certainly 3 times 15 would give us the total area of 3 slices. So this is equal to 45 centimeters squared. So in the next slide, what you're going to see is a circle and all the different elements of the circle that we have to be familiar with. So first of all, a circle has a center, and it has to be a center by definition, where you can draw any line from the center to the circle itself, and that line is going to equal a radius. So this line is a radius, just like this one is a radius as well. This green shaded region is what is known as a sector. So when we talk about sectors, we would be thinking of areas of, say, the slice of pizza. This here is known as the central angle. And it's always going to be a slice in terms of the whole circle, right? So this would be a piece of 360 degrees. Then, just as important is the definition of arc, because we're going to learn how to find arcs. And in this case, the arc that they are indicating starts here and ends here, right? So this section here, this part of the circumference, is an arc. Then sometimes you might have a line that does not go through the center. If there is a line, any line that goes through the center is known as a diameter. But if the line crosses the full circle and doesn't go through the center, then it's known as a chord. So this is a chord here. And this area that is cut out, so to speak, is known as a segment. So these are the parts of the circle that we need to be familiar with. Okay, so here we are on example 5.2. And it says, on golf courses, the grass is carefully watered to make sure that grass receives neither too much nor too little water. On a certain area of a golf course, a lawn sprinkler is set to spray an arc of 150 degrees with a spray distance of 3 meters. Calculate the area of grass that is watered by this sprinkler. Okay, so because we're talking about circles and areas, we have to remember the formula for the area of a circle. So that is that the area is equal to pi r squared. So this is what we would do to find the whole circle's area, right? But in this case, we only want a portion of it. So what portion do we want? Well, we want 150 out of 360. So this is a fraction of the circle that we need to find the area for. Therefore, we can find this particular sector's area by going 150 divided by 360 times pi r squared, in this case 3, so 3 squared. And then we plug that in the calculator, round it to 3 significant figures, and we're going to get 11.8 meters squared. Okay, everyone, so here we are now on example 5.3. And they're talking about some airplane routes that come very close to flying over the North Pole. The route from Dubai, United Arab Emirates, to Seattle, US of A, comes very close to the North Pole. In this case, the distance of the flight can be estimated by the arc length. Given that Dubai's airport is 25 degrees north and Seattle's airport is at 47.5 degrees north, as shown in the diagram, estimate the length of the flight between these two cities. The radius of the Earth is approximately 6,370 kilometers. Okay. Part A, calculate the distance along the Earth's surface that the plane must travel. Now, remember that arc lengths are related to circumferences, because that's just a piece of the circumference. And let's recall that the circumference of a circle is given by 2 pi r as a formula. So really what they want us to find is a fraction of the total circumference. And that fraction is going to depend on the central angle. Now the central angle is not the 2 that they gave us, but rather this one here in between. And it's easy to find because we know that if this is the equator line, then it's splitting the Earth into 2 hemispheres. And that means that we're talking about 180 degrees, right, for the total hemisphere. Therefore, this has to be 180 minus 47.5 minus 25. And that would give us 107.5 degrees. So that means that we want to calculate 107.5 over 360 as a fraction of the total circumference. So this times 2 pi r. And r is going to be the radius of the Earth, which is approximately 6,370 kilometers. So let's plug this into the calculator, and we're going to see that it's going to give us approximately 11,952 kilometers. Okay, so that would be the answer to A, but how about the answer to B? Because in B, they changed the circumstances a little bit. Because they say that assuming the plane travels at a constant elevation of 10 kilometers above ground level, estimate the actual flight distance. So that means that we have to add another 10 kilometers here. And by doing that, what we really have to do is add 10 kilometers to the radius. So let's just substitute here in the formula. Instead of a 7, or instead of 70, I'm going to write 80. So instead of 6370, let's use 6380 and calculate the result. So once we plug that in the calculator, we're going to get a number that is slightly higher, which is 11,970 kilometers.